Imagine passing a secret note across a crowded room where everyone can see it. So you and your friend agreed on a code beforehand that looks like nonsense to everyone else. That's encryption. Here's the promise. Your messages, passwords, and bank details travel across the open internet, where strangers can see the traffic, yet they stay unreadable to everyone but the right person. We'll show you how. First, a reframe. The internet is a public space. Your data passes through many machines you do not control. Routers, cables, and servers owned by strangers. Hiding the message is not the goal. The real goal is to make your data unreadable to anyone without the key. The message can travel in plain sight, and it still looks like meaningless noise to every machine along the way. So what is encryption, really? It is scrambling readable text into nonsense using a key, and only the matching key can turn that nonsense back into the original message. Same key, both directions. Now, the lock-and-key idea. A key is just a secret number. A short number is easy to guess. A long number with billions of possible combinations becomes practically impossible to guess. But this raises the crowded room problem. How do two strangers agree on a secret code when everyone is watching the exchange? You cannot just shout the key across the room without the eavesdroppers hearing it too. Here is the clever fix: public and private keys. Think of two matching pieces. A public lock anyone can use to seal a message, and a private key that only you hold to open it. This is the magic part. You share the public lock with the whole world. You never share the private key. So two strangers can exchange sealed messages without ever sending the secret part across the room. You see this every day in your browser. Look up at the address bar. That little padlock icon and the letters HTTPS mean your connection to that website is encrypted from your device all the way to their server. This matters most on public Wi-Fi. At a cafe or airport, you share the network with everyone nearby. With HTTPS, even if someone is listening, they only see scrambled traffic, not your password or bank details. You might wonder, why can we trust this? Encryption relies on math problems that are easy to do in one direction, but practically impossible to reverse. Multiplying two huge numbers is quick. Undoing it takes forever. Think of it like mixing two cans of paint. Combining them is easy. Separating that mixed color back into the exact original cans is something nobody can practically do. Encryption uses that same one-way idea. Now, what encryption does not protect? If someone steals your key, the lock no longer helps. The thief just walks in. The math is perfect, but a stolen key turns that strength into nothing. It also can't protect you if your device itself is stolen or unlocked. Once someone is inside your phone or laptop, your messages are already decrypted on the screen, ready to read. And it cannot protect you if you are tricked into handing the key over yourself. A fake email, a fake login page, a friendly phone call. If you give away your password, the lock simply opens. So encryption is strong, but it only protects the message in transit and at rest. It does not protect bad habits, weak passwords, or careless clicks. The math is your shield. You still have to guard the key. Quick recap. The internet is public. Encryption scrambles your data into nonsense using a key. Public locks let strangers seal messages for you. Only your private key opens them. The padlock in your browser does this every day. In one sentence, encryption turns your data into nonsense for everyone except the person holding the right key. The math is the strong part. Your habits, your device, and your key are the human part. If this helped things click, subscribe to Tech Actually for simple explainers on AI, tech and how things actually work. Thanks for watching, and we'll see you in the next one.